Hey there, welcome back to our Sky Tonight program. My name is Seth Mayo. I am the curator of astronomy for the Loma Planetarium at MOAS, and in this program, we are covering the dates of May 16th through May 22nd. We got a lot of interesting things to talk about. We're going to first say farewell to the brightest star in our sky, Sirius, in the west and southwest. Then we're going to say hello to the great summer constellation of Scorpius and really talk about an image in that area taken of the center of our galaxy that was just released. It is very cool. And then we're going to look towards the east in the early morning again, where all those planets have been lined up, and look at the moon getting pretty close to one of those planets in the sky. So let's get to it. At this time of year, we can finally start to say farewell to the brightest star we can find in our sky, and of course, that is the star Sirius here in the west and southwest, depends on your latitude here, but it is an amazing star that you've probably seen before in the sky and now getting very, very low. But we want to mention it before it sets, and then we won't see it again into the early morning later in the summertime when it starts rising with the sun. But for now, we still see it in our evening sky shining like this bright beacon. And as you might already know yourself, Orion's belt is always a good tool for finding that star, but recently we did say farewell to Orion, but you can see Orion just peeking here in the west. We really don't have a good view of him now because the sun's glare is kind of obscuring him a bit. And you can see a little bit of Orion's belt pointing to that bright star, Sirius. You usually don't need the belt to actually find it because Sirius is so bright in the sky because it's one of the closest stars to us at about 8.6 light years away. It's one of our next door neighbors in our celestial neighborhood, and that is the main reason for its brilliance. One thing I do mention in my planetarium shows and stargazing parties is that even though Sirius is considered a close star to us, 8.6 light years is no close distance. That is so far for us. That's about 50 trillion miles away. To put that in perspective, if you sent the fastest spacecraft that we've ever put into space, the one that's going to achieve a record speed of 430,000 miles per hour later in its mission. This is called the Parker Solar Probe, a sun-orbiting spacecraft that studies the sun, of course. And you pointed the Parker Solar Probe to that star going at its fastest at 430,000 miles per hour. It would still take that probe about 13,500 years to reach this star. That is still a mind-boggling distance away. But again, for stars in our sky, one of our close neighbors. Now, if you did travel that distance, 8.6 light years, and could get there, you would discover this is actually a binary star system, a pretty well-known one throughout history. It's actually two stars. One is called Sirius A, which is a larger white hot star, about twice as massive as our sun and about 1.7 times the size. So it's hotter and more luminous than the sun. And it has a little companion called Sirius B, which is a white dwarf star. It's actually the dead core of a much larger blue star that died, got really large, shed its gas into space, and what remained is this white dwarf that's just a little bit smaller than our planet, but has about the mass of something like our sun. So it's very dense. And those two objects actually orbit each other every 50 years. But that's not, again, the main reason for its brightness. It's, again, its proximity to us is what makes it so bright. And when you do look at it low in the sky especially, you're looking at it through more of the curvature of our atmosphere, which means you'll see it really shimmer. That's that really extreme twinkling effect, and you'll see it go through all sorts of different colors between red and blue and white and yellow, and it kind of flashes very quickly. And so I get a lot of questions about that, and that's just because all stars twinkle, but especially when they're low in the horizon. And since Sirius is so bright, that twinkling effect is amplified and then is very noticeable. And one last thing I'll mention about Sirius is you may know it's also called the Dog Star because it's situated inside the Dog constellation, one of Orion's hunting dogs called Canis Major. And there it is at kind of the bottom of the head, or sometimes it's known as the jewel of the collar of the greater dog, Canis Major. Or sometimes the name of the dog is Sirius, just like the name of this star. So we can say farewell to the star Sirius. It's still lingering in the west and southwest. Make sure you check it out before it completely goes away. But of course, we'll look forward to it again in late summer in the early morning, and then it will rise until it makes its way into our winter sky in the evening. Now, as we make our way to the east and southeastern part of the sky where objects rise from, there's something I want to mention that is now beginning to be visible in our sky. Now, I usually don't mention it this early, but this relates to an amazing image that was just released. But what we can kind of say hello to, at least in our evening sky, is a famous summertime constellation. We can see a little bit of it here in the east and southeast, just rising, at least in our location, as we get into about 9 and 10 o'clock here. But let's kind of move ahead in time. We're going to watch the head and maybe one of the claws of Scorpius, the scorpion, rise here. So we'll get it just high enough so we can see a few other objects around it here. And as we do so, we can see a really beautiful area of the sky. So we'll stop right about here. And Scorpius, the scorpion, looks like a giant S in the sky. Now, one thing I just want to mention is that this is a very southerly constellation, so if you're in more southern latitudes, at least here in the northern hemisphere, you'll have a better and better view of this. Doesn't mean you can't see it farther north, it's just a little bit harder. It'll be a lot lower in the sky. But at least here in Florida, we're pretty far south, so we have a pretty decent view of this. The S shape is the main part of the body of Scorpius that we've mentioned before. I'm going to click on its brightest star, Antares there, the heart of the scorpion. So usually this is kind of the head or one of the claws of this mighty scorpion, this giant beast from Greek mythology. Here is the body, and then of course the tail and the signature stinger of a scorpion right there. So really nice summertime constellation now starting to make its way into our evening sky. And not far away from it are the stars of Sagittarius that I like to mention looks like a teapot in the sky. That's the asterism that's pretty well known in this area. Here's the handle of the teapot, there's the lid and the spout. But this is a half-man, half-horse creature, a centaur, also from Greek mythology, that we find right there. Those two kind of go hand in hand as great summer constellations and, of course, zodiac signs. This area is so cool to look at, especially if you're in a dark place, as this is a very bright area of the Milky Way, you know, that disk that kind of reaches or spreads across the entire sky, that kind of milky-looking object. Well, that is the brightest section of it, and it's actually the center of our galaxy. And I love mentioning this, that you can find the center of our galaxy relatively easily, especially if you can locate these constellations. So if you look near the tail of Scorpius and kind of near the arrow of Sagittarius here, or the spout of the teapot, if we turn off the picture, that might help you to kind of see that here. There's that spout shape there. Right about here is that central region, and that's why this is the brightest part of the Milky Way. That's kind of the bulge or the central region where there's a lot of stars and gas and dust in that area. And what is so exciting about this area, and you might have heard about this, maybe you saw it on the news, just recently, for the first time, a picture of the center of our galaxy was just released, and that is a picture of the black hole that we have assumed for many years was there at the very center, located right in this area. It is an amazing picture, and I'll show it to you in just a moment. But this area has been quite known in radio astronomy for many, many years. There is a very bright radio source here called Sagittarius A star. Normally radio sources, so areas where a lot of radio waves are emitting from, are labeled with letters, and then in the constellation it resides in. So this is technically in Sagittarius, and it's A, so that means it's the brightest, but they put a star next to an asterisk, meaning it's an exceptionally bright radio source. So that's always made it a very interesting area of our sky, especially in the Milky Way. So it's called Sagittarius A star, sometimes you hear Sag A star. And in that region, we have assumed that there is a black hole. One of the ways we figured that out was we've actually observed stars going around at tremendous speed around something that is invisible there. And what we've assumed that that must be a black hole. And a black hole is matter that is so dense and confined to such a small area that the gravity is so strong that even light cannot escape it if you get too close to it. So black holes are invisible, and they're really, really mysterious. They're some of the most mysterious and strange objects in our universe, and of course you've probably seen movies related about them. You know, there's that Disney movie Black Hole, or a more recent movie Interstellar that deals with black holes, and there's other great science fiction works that deal with these really strange objects. But the one at the center of our galaxy has been one we've been trying to figure out, and those stars orbiting around it helped us understand there is something there. And by understanding those stars moving at tremendous speed around this object, whatever it may be, we were able to figure out the mass of this black hole at about 4 million solar masses. So that means it's equivalent to the mass of 4 million of our suns compact into a region about the size of Mercury's orbit is around our sun. And that is so dense and the gravity is so high that has formed a black hole. Now, just 2 or 3 years ago, the first image of a black hole was released, at least around a black hole, and we definitely talked about on this program on several occasions. And this black hole, the first one we ever imaged, is in a faraway galaxy called M87. And the reason why this was the first one ever imaged was because it's really big and really massive, and one that was a little bit easier to image due to its massive size. This is a 6 billion solar mass black hole that lies about 53 million light years away. And of course, the image looks like a big, giant, oddly shaped orange donut. That's the joke you hear all the time. And it really looks like that. But what we're finding is the gas around the black hole, what's called the accretion disk, that's rubbing together and emitting light that we can detect. So this first image was seen in radio waves from 8 telescopes, 8 radio observatories around the world in this collaborative project called the Event Horizon Telescope, combining these together into basically an Earth-sized radio telescope to detect something like this that's very, very far in space. And it was an amazing revelation. Well, finally, that same collaboration, the Event Horizon Telescope, or the EHT, released this image of the center of our galaxy, the black hole at the very center, and there it is. I know, another strange looking kind of misshapen orange donut, but this is an amazing image, probably one of the most amazing images now in astronomy and astrophysics. We finally have seen around our galactic center black hole, around Sagittarius A star. And this was quite difficult to image, actually harder than that first image I showed you from the black hole in M87, because this one is much smaller, about 1,500 times smaller, but about 2,000 times closer to us. It's so small, it's like imaging something like the size of the opening of a donut on the moon, or maybe the size of a ping pong ball or a quarter on the surface of our moon. That's how tiny it is of an object in the sky. And it takes a large collaboration of telescopes to resolve something that small. It's actually way smaller in the sky than the M87 black hole. And the other tough part about it is it's changing much more rapidly because of how much smaller it is. The material around the M87 black hole, which I didn't mention, is called Poway. It's a Hawaiian name. It's moving around it and falling into the black hole at a slower rate, usually taking days or weeks for the material to go around it. So it's a little slower and not as dynamic. But the black hole in the center of our galaxy, the material swirling around it only takes minutes. And so it's changing quite frequently. So it's really hard to take a picture of this because of that changing environment around it. And actually the image of this black hole is fuzzier and blurrier because of that fast changing environment. Much fuzzier than Poway from 2019. But still, from those 8 observatories, those radio telescope observatories around the world, all that data was collected and then put on hard drives and sent to the Max Planck Institute in Germany and MIT here in the United States. And that data is put into supercomputers to finally piece that all together to give us this black hole image here. And what we might be seeing are those bright areas where the magnetic field is supercharged and allowing the energy to be a little more intense versus those other areas that are dimmer. But we're still trying to unravel and sort of piece together what's going on here. But what's amazing is this is another confirmation that black holes exist in the universe. It was still kind of a theoretical thing that black holes could be a thing because we can't see them. And if we can't observe them, it's hard to tell if they're really there. But this helps confirm Albert Einstein's theory of gravity and relativity. Now, over 100 years ago, he predicted that mass can warp space and time. And from that understanding, other astronomers and physicists realized that you could take that and at its extreme, if you have something so dense that curves space-time infinitely, you can get something called a black hole. And this kind of tells us that that really exists in the universe. Now, again, this is not actually a picture of a black hole. We can't see the black hole. That dark area in the center is what we call the shadow of the black hole, but we can see around it. We can see outside of something called the event horizon. The event horizon is the point of no return. If you pass that threshold, not even light can escape, let alone anything else in the universe. So you don't want to get close to a black hole, but around it, light can orbit around it, and the gas can orbit around it in a nice, sometimes stable orbit, just depends on how close it is. But if you're too close, you eventually will fall in, including the photons of light, and in that area, you cannot see it. But we can study the environment around black holes and understand how they work, how they change over time. So we're going to learn more and more about this area over time. This is not the only picture you're going to see of our galactic center black hole. And why do we do this? What's important about this weird orange donut-shaped thing? Well, we think that the formation of galaxies may have started with giant black holes. So our Milky Way galaxy, being a spiral galaxy, may have its roots, its beginning, tied to the black hole in the center, which relates to us and our sun and planets forming as well. So we're not entirely sure if black holes come first in galaxies. There are other ideas. Maybe a lot of stars and mass in the center of a galaxy can squish into a black hole. We're still trying to figure out what came first, kind of a chicken or the egg kind of situation here. But this is getting us closer to helping us understand that. And we are seeing and discovering that most galaxies in the universe probably have black holes in their centers. Nothing to worry about, of course, because black holes aren't just big vacuum cleaners sucking up everything in the universe. You have to get very, very close to them. But they're so interesting and so fascinating and mysterious, and this gets us just a little bit closer to understanding them. So can't wait to see what we learn more about our galactic center black hole and other black holes in the universe. And now you know, if you want to find it, at least the location of it, you can look between those two great summer constellations of Scorpius and Sagittarius, in particular Sagittarius in this area where you can find the Sagittarius A star, the galactic center black hole, about 26 to 27,000 light years away. And just a quick update in the early morning, we've been talking about all of those planets that have been lined up and kind of moving around in various ways, and we still have 4 of them that you can find if you're getting up between maybe 5 and 6 in the morning, where you can see all 4 of them at once. But you'll notice again, just to kind of give you an update here, this is Venus down here closer to the horizon. That's the brightest of all 4. And we have Jupiter at the second brightest here. That's also quite nice. And not far away from it, a bit dimmer, is Mars. And keep in mind, as we go through the rest of the month here, you're going to see Jupiter and Mars get closer and closer as it gets to a conjunction by the end of May. And then a little farther away is Saturn up here, the beautiful ringed planet. But one thing I just want to show you, at least as it pertains to this week, is that the moon will actually pass by Saturn. So if we move here from the 20th, which is Friday morning, we'll see the moon still at a waning gibbous phase, and then we'll go ahead to Saturday morning, the 21st, and then by Sunday morning, the end of the week here, the 22nd, there you'll find a last quarter or half phase moon here, pretty close to Saturn. So that would be a nice conjunction between those objects. They're not super, super close, but close enough to be noticeable in the sky looking towards the east and southeast. So it's still nice to find all of these solar system objects in this area. That's it for another edition of our Sky Tonight program. Thank you very much for tuning in. And if you find yourself in Daytona Beach, please stop by the Museum of Arts and Sciences and the Loman Planetarium. We are running shows all the time. And if you want to see our schedule, please check out our website and our various social media channels where we're posting some great content about what we do in the museum and, of course, about astronomy and space. And thank you very much if you already tune in to those programs and support us already. With that, we hope to see you back here again. Thank you, take care, and of course, happy stargazing.